so the hard part's over now. We've done all the examples. We looked at all the different concepts. So now we're just going to look at some conclusions to wrap up the lesson. So for any exponential function of the form y equals a times b to the exponent x minus d plus c, so the base function would be y equals b to the exponent x, okay? A, k, d, and c apply different transformations to that graph. And so what we've noticed so far is that the domain for all the functions have been the same. The domain for every single function was all real numbers. The range changed. It was either greater than or less than, depending on whether the graph had a vertical reflection in the x-axis. So if there was no vertical reflection in the x-axis, so if you had a positive value for a, then what the graph ended up looking like is a function where the entire graph is above the asymptote, okay? But if you had a reflection in the x-axis, you ended up having a graph that was facing downwards or going below the horizontal asymptote. So all the values of y were below the value of the asymptote, okay? Where did the value of c come from? Well, that's the equation of the asymptote. Y equals c is the equation of the asymptote because c tells you how much the graph has shifted up or down, and that is what affects the horizontal asymptote. So as you move the graph up a certain number of units or down a certain number of units, that takes the horizontal asymptote with it. And so that's how you can find the equation of the asymptote. And so depending on whether your graph is above or below due to a vertical reflection, your range values will actually change. Okay? So when the value of a is greater than 0, so what this means is that there's no reflection, so a is positive only. If the value of b is greater than 1, then you're still going to expect a graph that is increasing. So an example of this is y equals 2 to the exponent x, okay? So if the value of the base is greater than 1, then the entire graph will be above the asymptote because there was no reflection in the first place. So here I know that there's been a vertical shift up, so maybe I'll change the way I've written the equation to y equals 2 to the exponent x plus 5. But essentially what happens is the entire horizontal asymptote is moved because the graph has shifted up 5 units. And you'll notice that because there is no reflection and the base is positive and greater than 1, as the value of x gets larger, so does the value of y. And as the value of x gets smaller, the value of y starts to approach the asymptote that we have drawn here. Now, if the value of the base is between 0 and 1, no reflection still in the x-axis, no reflections. So here's an example of that. Y equals, let's say you have 1/2 to the exponent x and then plus 5. So because this is already a decreasing graph, this will stay a decreasing graph because there has been no reflections applied to it, okay? Shifting the graph up 5 units just moves the entire graph up along with the horizontal asymptote. And so the graph is still decreasing. That hasn't changed. So what that means is, as the value of x gets larger, the value of y approaches the asymptote, which in this case is 5. And as the value of x gets smaller, the value of y approaches positive infinity. Now, if there is a reflection, so that's what we're going to look at next. So if there is a reflection, it's a little bit different. Because there's been a reflection, now the transformation is going to be slightly different and the behavior of the function is also going to be slightly different. So if you have a reflection, so this tells me the value of a is negative. So if you have something like y equals negative 2 to the exponent x plus 5. So the negative here indicates that there's been a reflection. The base is greater than 1. There's your exponent of x, and your graph has been shifted up 5 units. What ends up happening is the graph goes from being increasing, which is what we looked at earlier. So it goes from being increasing to being decreasing instead. And the reason for that is because the graph has been reflected along the x-axis. So instead of going up and to the right, now it's going to go down and to the right. Okay? So as x gets larger, the value of the function gets smaller. And as x gets smaller, the value of the function approaches the asymptote. Now if the base is between 0 and 1, so if you have something like y equals negative 1/2, so a is negative, and the base value is 1/2, so between 0 and 1, and there's your vertical shift up again. What you'll notice is that because when you have a base that's less than 1 but greater than 0, normally the graph is increasing, but the fact that you have a reflection here causes the graph to reflect along the x-axis, move down below the asymptote, and increase instead of decrease. So if we compare it to the previous one we looked at, earlier we had a decreasing graph. As you reflect it, it goes from coming down and to the right to going up and to the right, much like what we have here. And so instead of a decreasing graph, now you have an increasing graph instead. So as x gets larger, y approaches the asymptote, and as x gets smaller, y approaches negative infinity. And that's about it. So here's your assigned work. You're doing some questions in your textbook, and you're going to watch the video on lesson 5 tomorrow night, which is on modeling exponential functions.